Section 7.3 shows how to calculate the areas under any normal curve. The procedure is as follows. To find areas and probabilities for a random variable x that follows a normal distribution with mean mu and standard deviation sigma, convert x values to z values using the formula. So this is the same formula as the previous section. Z equals x minus mu over sigma. Then use table 3 of the appendix to find the corresponding areas and probabilities. So in the previous section, section 7.2 provided examples on how to calculate the z-score and how to look up the z-values in the normal distribution table. In this section, we will put both steps together. Example 5. Find the probability that an x value selected at random from this distribution is between 11 and 14, with mu equals 10 and sigma equals 2. In symbols, find the probability that x is between 11 and 14. Step 1 is to draw the area under the curve. Step 2, convert the x values to standard z values. So we're taking the information that's provided and plugging it into z. We first start with z1, which is our lower bound of 11. So x equals 11, mu equals 10, and sigma equals 2. So our z for the lower bound is 0.5. Then we look at z for the upper bound, where x equals 14. The mu is still 10, sigma is still 2. When we do the math, we get a z value for the upper bound of 2.00. Step 3 is to look up the probability associated with the z-scores. So we're looking for the probability of x between 11 and 14 equals the probability of z between 0.5 and 2.0. That's what we just calculated. When we look up those values in the back of the book, table 3 in the appendix, we get a probability of 0.9772 associated with z of less than or equal to 2.00. And we get a probability of 0.6915 associated with a z value of 0.5. Doing the math, we get 0.2857. Lastly, we need to interpret. The probability is 0.2857, then x values selected at random from a normal distribution with mean 10 and standard deviation 2 lies between 11 and 14. Sometimes we need to find z or x values that correspond to a given area under the normal curve. This situation arises when we want to specify a warranty period such that a given percentage of the total products produced by a company last at least as long as the duration of the warranty period. In such cases, we use the standard normal distribution table, but in reverse. When we look up an area and find the corresponding z value, we are using the inverse normal probability distribution. Example 6. Find x given a probability. Magic Video Games, Inc. sells an expensive video games package. Because the package is so expensive, the company wants to advertise an impressive guarantee for the life expectancy of its computer control system. The guarantee policy will refund the full purchase price if the computer fails during the guarantee period. The research department has done tests that show that the mean life for the computer is 30 months with standard deviation of 4 months. The computer life is normally distributed. How long can the guarantee period be if management does not want to refund the purchase price of more than 7% of the Magic Video packages? Step 1, draw the area under the curve. As you can see in the drawing, the 7%, what's in blue, these lifetimes fall short of the guarantee period because the company is willing to give up 7%. Anything greater than that, these lifetimes exceed the guarantee period. Step 2, find the z-score associated with given probability. The area value is 0.0700. Since this area is not in our table, we'll use the closest area, which is 0.0694, and the corresponding z-value of z equals negative 1.48. Step 3, we need to convert the z-score to an x value. So using the formula x equals z times sigma plus mu, we enter in that negative 1.48 for z. We use the provided values for sigma and mu as 4 and 30 respectively. And doing the math, we get 24.08 months. For the interpretation, what this means is the company can guarantee the Magic Video Games package for x equals 24 months. For this guarantee period, they expect to refund the purchase price of no more than 7% of the video games packages.